gain. Now H parameters. So see here, H parameters, first one input impedance. So it is not HIB, it is HIE. I understand, you know why I'm writing it as HIE. H is hybrid, I is input impedance, and now I am going to use common emitter. And diagram paranga, what is the input voltage? VBE. What is the input current? IB. What is the output voltage? VCE. So VBE by IB at constant VCE, that is the input impedance. Input impedance, now see the input side. Okay, don't look at the output side. Output side, the voltage will be constant. See here, delta VBE by delta IB at VCE constant. So delta போடுறது just to see the change in VBE divided by change in IB. Delta is just like differentiation. dVP போடுவோம்ல, D க்கு பதிலா delta போடுறோம் because the variation is very, very small. And see this value of input impedance, HIE is 500 to 2000. So common base க்கு நம்ம பார்த்தோம். What was the value for common base VCA and HIB? What anybody remembers the value for HIB, whatever we have seen for common base? How much ohms we got? HIB
20 to 50.
20 to 50, sir.
20 to 50. I told you that value is very, very low because when the input impedance is very, very low, the circuit will draw a huge amount of current from the battery. But see here, the input impedance value is very, very high, which will ensure that the current drawn is always the safer limits only. Okay, the HIE of our common emitter configuration is in the range of 500 to 500 ohms to 2 kilo ohms. So this one, among all the configuration, this common emitter only provides a very high input impedance. That is the reason, one reason for picking common emitter as the mostly used amplifier in our circuits. So one condition is fulfilled. The input HIE value is very good. It is very high, which means that the current drawn is going to be very, very less. Next one, output admittance. I'll go back to the diagram. Output admittance. At output side, you see admittance is reverse. Admittance is I by V. Correct? Output side, the current is IC and the voltage is VCE. So IC by VCE at constant IB. Okay, see, let us see whether what we are saying is correct. Yes, HOE. It is called as HOE. H is hybrid, O is output impedance admittance, and E is common emitter. So delta IC by delta VCE at constant IB. And HOE value is 0.1 to 10 micro ohms. So this input impedance value is ohms, admittance value is mho, or you write it as MHO, or you write it as Siemens capital S. All these have the same meaning. Okay, forward current gain. So forward, I'll go back to the diagram again. Forward current gain now, output by input. What is the output current? IC. What is the input current? IB at constant VCE. Okay. So HFE equal to, it is called as HFE. HFE equal to hybrid forward current gain. E stands for common emitter. So HFE equal to delta IC by delta IB at constant VCE. And we have seen in a common base configuration, the current amplification was not there because it was in the range 0.9 to 1. So effectively current is not getting amplified. So now I told you common base configuration is not used for current amplifier. But see here, what is the value of this HFE is nothing but beta, correct? So see what is the value of beta? Beta is 20 to 200. So current amplification is taking place here. So if the input current is, for example, I'm saying, okay, 1 ampere now, output current will be 200 amperes. So it is amplified 200 times. Amplified and the meaning the current input current is multiplied by this value of beta. So this transistor provides current amplification also. Very, very important thing. So see, all parameters are very favorable to common emitter. Impedance is very high, good for me. Output admittance is also normal value, it is good for me. Current gain, yes, common base has no current gain, but common emitter is providing me a very good current gain. So current gain is also there. Now reverse voltage gain. Reverse voltage gain is input by output voltage. See the diagram. Input voltage is VBE, output voltage is VCE at constant input current. Okay. HRE. Okay, H is hybrid, R is reverse voltage gain, and E is common emitter. So HRE equal to delta VBE by delta VCE at IB equal to constant. So this is, so see here 10 power minus 5, 10 power minus 4. So reverse voltage gain, input by output is 10 power minus 5. So output to input என்ன இருக்கும் 10 power 5. So voltage gain is also there. So see, all the properties are for an amplifier are getting satisfied here, correct? So four properties should be satisfied. All these values of H parameters should be satisfied. Common base la pathina, two values were not satisfied. What are the two values not satisfied in common base configuration for an amplifier? What are the two values not satisfied in common base configuration? What are the two values not satisfied in
Current
common base?
and resistance.
Yes, input impedance was very poor and the current gain was not there. But here you see input impedance is very high, good for me. Current gain is also very high, good for me. Voltage gain is very high, good for me. See, when there is both current gain and voltage gain, what gain will also be there in an amplifier? Can somebody answer this question? In common emitter amplifier, I told you there is current gain as well as voltage gain. So if both are there, what gain will be also there in that amplifier? What also will be multiplied? If current is multiplied, voltage is multiplied, what also will be multiplied? Current voltage சம்பந்தப்படுத்துற இன்னொரு parameter என்னது?
Power.
Power, very good. So this common emitter configuration will amplify your power also. So if you give a audio signal which is having a very low power, the amplified version will be having a huge amount of power. So உங்களுக்கு common baseல this power amplification was not there because there was voltage amplification, but there was not current amplification. But in common emitter configuration, since you have both voltage and current amplification, this amplifier will be in default, it will be having power amplification also. That is the one thing you have to keep it in mind. Okay. And you know voltage is going to be, and you know power is going to be P is equal to V into I, correct? So already voltage is amplified. So voltage is amplified. See, you are amplified by 10 power 5. Current is amplified by 200. So these two will be multiplied. The power will be amplified by 200 into 10 power 5. So see how much amount of power is getting amplified by the common emitter amplifier. That is why among the three configuration I told you, common collector picture liye varadu. Among common base and common emitter will be mostly used because of all these beautiful properties of common emitter configuration. Any doubt in H parameters of common emitter configuration you have, you can ask. I'm going to pause for a few seconds.